Hey everybody, welcome to our last lesson of bonding as a unit. I'm excited to dig into this one because I think it's one of those lessons that ties together so many pieces from our entire unit. And we're going to be talking a little bit about ionic conductivity and why ionic substances create are able to conduct as aqueous solutions, but not in the solid form. Cool, so let's dig in. All right, so first and foremost, we need to kind of discuss what it means, what electricity is and what it means to be a conductor. And so every year that I teach this, whenever I say, okay, guys, how do we define electricity? A lot of you guys already have a great general understanding of what it means or what electricity is. But because that base word of electricity looks like electron, students tend to think that electricity is a flow of electrons, which can be true, right? Metals do conduct because of that flowing, the flow of those electrons that exist in metals, but it's not just limited to that. So let's go ahead and define electricity. So electricity is going to be defined as the flow of charged particles. Okay, and again, that could mean electrons like in metals, or it could mean other charged particles like ions. Now, covalent substances have absolutely no conductive properties whatsoever. So why would that be the case, right? So if we think about covalent substances, remember that covalent substances are held together by sharing of electrons. Okay, so covalent substances are held together by the sharing of electrons. And because of that, right, we don't create any ions, or there are no free moving or delocalized electrons. And so covalent substances, regardless, they will never conduct. Okay, never conduct. No ions or electrons that are free moving. Now, ionic substances do not conduct in their solid phase, okay? They don't conduct in their solid phase. And so in order to explain why that's the case, we need to look at the structure of an ionic solid. Now, if you're following on my guided notes sheet, I've already provided that diagram for you, but if you are not, let me go ahead and just sketch that here. So an ionic solid is created or is made of what's called a crystalline lattice, or a really organized structure of alternating positive and negative ions. Okay, and you'll notice from the diagram that the way that they alternate is so that the positives really only come in contact with those negatives and they're attracted and there's no issue there. Okay, so an ionic solid is created by alternating positive and negative ions that are locked into place okay, they're locked into place and no charged particles are free to move. So if you think of the definition of electricity or the flow of charge, then looking at this structure, you can see that no charge is able to flow. These positive and negative ions are locked into place there. And if they were to even start to shift from that place, right, what would end up happening is we would end up seeing some form of repelling, okay, in this structure. Okay, so again, ionic solids do not conduct electricity at all, right? If you were to take a light bulb, put it into a bunch of salt in the kitchen, right, we would not get any sort of conductivity to happen. Okay, cool. Sorry. So now thinking about ionic substances as liquids. Okay, sorry everybody, I paused there because I thought I was going to sneeze, so sorry about that. Now let's really quickly talk about ionic substances as liquids. Now, if you think about the definition of just a liquid, when we talk about movement, talks about literally flow, right? Solids vibrate in place, but liquids are able to flow. And so by literal definition of a liquid, when ionic substances are in the liquid form, they should be able to conduct because their positive and negative ions are flowing around, literally a flow of charged particles. Now, again, if you're following along on my notes sheet, I've given you that diagram, but just trying to think about what that liquid might look like, right? We might have these particles now, they've moved from their lattice structure, and they're not quite as limited because of the structure of a liquid in terms of their organization, okay? And so ionic liquids, okay, are able to conduct because our positive and negative ions flow freely, okay, as a liquid. Now, that leads us to our last point of discussion, which is when we create an aqueous solution or an ionic substance dissolved into water, why are we able to conduct electricity? So I think at least from here, understanding that covalent substances do not conduct on their own, ionic solids cannot conduct on their own, but when we take water, which is covalent, and an ionic solid, and we put them together, it creates a conductive or a place of conductivity, right? That's really intriguing. And so this is where we're going to have to take a minute to just really go back and think all about everything from this unit. So let me first start with just sketching out here, or let me actually just go ahead and write the question, because again, I think it's really important to keep this in mind. So why can ionic solids conduct once dissolved in water? Okay, now I want to start by just sketching out a beaker and talking a little bit about the structure of water. Okay, so here we have our beaker. Okay, and in that beaker, we are going to put some water. So I guess I could, since I'm using colors, make that water blue. It doesn't really matter. Okay, but here we have our water. And my question then, I guess, is let's focus just a moment on that structure of water. Okay, so just to review, okay, to draw the Lewis dot structure of water, okay, I have H and I have O. And again, if you follow along with the electron dot filling diagram, okay, we know that the first two sets of electrons are paired, and then we're left with two unpaired electrons, one in the position of the bottom and one to the left-hand side. And so when we create the structure of water, H2O, we have a bonding pair that's formed here and a bonding pair that's formed here. And as a result of that, our water structure looks like this. Okay. And in order to talk about why it's going to help us create a solution that can conduct, we need to review the concept of molecular polarity. So keep in mind that H and O do not share their electrons equally, okay? H has an electronegativity of 2.2, and O has an electronegativity of 3.4. And as a result, we create partial positive and partial negative, or as we call them, dipoles, okay, from that unequal sharing of electrons. And those dipoles created will be a partial positive on our H, okay, on both bonds, and a partial negative on the O side of that bond. So we have polar bonds, okay, that create the dipoles, which as a result of those dipoles, we then create a polar molecule, right? An overall unequal distribution of charge. So think of it this way. We have all of our negative, including our partial negatives, sitting to one side of our molecule, and all of our positives sitting to the other side of our molecule, right? So over here. So as a result of this, we create this kind of massive overall positive charge on this side of our molecule, and this massive overall partial negative or negative charge on this side of our molecule. And this creates a polar molecule. So water is a polar molecule which has an unequal distribution of charge, okay? And it results in, again, that massive partial negative and massive partial positive. Now that we've reviewed that, let's put a few water molecules into our beaker, okay? So we can see how that will impact our ionic substance when it goes into the beaker, okay? So I have my two water molecules. Just to keep things kind of easy and consistent, I'm going to go ahead and label those partial negative, right? Those partial negatives on the O's and the partial positives on the H's, just so we can keep track of where those charges are, right? So we have these partial positives down here and over here. Now that we have our water in the beaker, I want to take a moment and just again remind you about ionic structure. So one singular ionic molecule is called a formula unit. So here I have two formula units of an ionic substance. They're positive and negative, that strong electrostatic force holding them together. Okay, and so it is very tightly held together. It's a strong bond, and the positive and the negative are attracted to one another. But what happens when you put that positive and negative ion into the solution? And I always like to teach this, even as silly as it is, and I don't know, maybe it's like weird to do it over a video because it's more fun in class, but I always talk about it like this. Imagine that positive and negative ion being your middle school relationship, if you've ever been in one. Okay, so you and your middle school significant other are attracted, you're bonded, you have this strong force of attraction. And then what happens when you go into a whole new dating pool, like going to high school? Okay, obviously there's going to be some other attractions that may or may not exist. Not to say that you and your middle school relationship won't survive if you're in one, okay? But if we dump this positive and negative ion in here, the positive ion says, well, hey, wait a second. Now there's these new negative charges that I can kind of interact with. And so what ends up happening is this negative ion now breaks apart. It separates from the positive, and where is it attracted to? Well, it's negatively charged, so it's going to become attracted to these partial positives, okay? And similarly, that positively charged ion is going to say, well, hey, I also have this new negative attraction that I can explore, so I'm now going to be attracted to this negative ion. And the same thing happens up here. Our positive is attracted to our negative, and our negative attracts to the partial positives. And so water allows us to help create this, this ionic solution that's conductive, because the partial positives and partial negatives of the water separate the positive and negative ions. So let's summarize that all for an explanation as why can they conduct electricity. So water okay, which is polar, separates the positive and negative ions due to the partial positive and partial negative charges created by its unequal distribution of charge. And as a result, okay, our ions are free moving and can conduct electricity. Okay, so I think that's just so super cool and so fascinating. And it also therefore explains why when we evaporate water out, salt is left behind, because the positive and negative ions now start attracting one another, okay, and they have a high melting point and high boiling point, so while the water evaporates, the salt is left behind. Now, really quickly, just to sum up just a few things about conductivity, I just want to remind you that metals conduct in any phase, okay? Covalent substances never conduct, okay? And ionic substances conduct only as liquids or solutions. Okay, everybody, that's it for today. I hope you guys enjoyed our discussion, and I will see you guys tomorrow. Have a good day.